What's up guys, welcome back to the channel. Today on this video we'll be solving the previous question paper that you see here. As you can see, this is a national certificate for mathematics N4, and this question paper was actually written on the 27th March 2025. It was an X paper and it also took about 3 hours to be written. So before we start though solving this question paper, I'd just like to say thank you very much guys for watching, subscribing to the channel, commenting, and not forgetting those who like and share the videos. If you haven't subscribed to the channel, subscribe to the channel because we have made lots and lot of videos on previous question papers and other mathematics problems. Right, so before we continue again on this question paper, so on this video we'll be solving from question 1 until question 5, but on this particular video we'll be solving only question 1, and we're going to leave a timestamp for each and every question that we are solving so that you can able to watch that question specifically, just in case you don't want to watch this question paper in a sequence order. All right, before we waste any time, how about we look at question 1 and let's solve it. All right, here's our question 1. As you can see here, question 1 consists of 1.1 and 1.2. Just in case you have a question paper with you, you will come across an error when it comes to numbering. So I already fixed that numbering error, which is 1.2 that was next to 1.1.1. So I fixed that. You won't be able to see it here. But anyway, let's just go straight to our question. So we're going to start with 1.1, where we can able to do the following problem. So I'm going to copy this question, paste it where there is space, and let's solve it. Right, let's look at 1.1. Now 1.1, they want us to make a neat sketch of the graph 4x squared minus 9y squared is equal to 36. Right, so before you make the graph or before you draw the graph here, you need to first identify what type of a graph are you required to draw here. When I look at this, I know that we have x squared with the coefficient of 4 minus y squared with the coefficient of 9. All this is equaling to 36. So when I look at this, I know that this is actually the central hyperbola, because the general formula for central hyperbola, it goes like this: is x squared divided by a squared minus y squared divided by b squared. All this is equaling to 1, right? For the fact that we have the coefficient for x squared and y squared, this means it's a central hyperbola. And also we have a negative sign between the two terms there. And all this is equaling to 1. So this tells us this is a central hyperbola. Now we need to simplify our equation so that it can be equaling to 1. So when you do that, we need to divide by 36 for each and every term that we see here. So we're going to do it here. We know that we have 4x squared divided by 36 minus 9y squared divided by 36. All this is equaling to 36 divided by 36. Now when you divide this 4x squared with 36, you'll be left with x squared divided by 9 minus, on the next term, when you divide 9y squared divided by 36, you're going to be left with y squared divided by 4. All this is equaling to 1. As you can see now, we have our 1 there. Now it's time for us to find our a and b. Remember, these values here, these are the values where our graph intercept. Our a is a value where our graph intercept at x. So let's find our a. Remember that a squared is equaling to, when you look at this graph, it's going to be 9. So when we're looking for a, we have to square root both sides here. So a is going to be plus or minus 3. There we go. And then as for b squared is equaling to 4, because 4 is dividing y squared. As you can see, b squared is dividing y squared. So when you're looking for b, we square both sides. We know that b is going to be plus or minus 2. There we go. Right, so just in case you don't know how the central hyperbola looks like, basically the central hyperbola looks like this, especially this one that we drew here. It's supposed to look like something like this. There we go, with a asymptote line. There we go. Right, x and y. In order for you to draw this graph, you need to also know that we have the asymptote line. So the asymptote line, the formula, it goes like this. It's y is equaling to plus or minus b over a multiplied by x. So in this case here, on this formula, we can say the asymptote line is y is equaling to plus or minus, what is our b, 2 over a, which is 3 multiplied by x. So these are two asymptote line. One is positive and the other is negative. So when it's like this, we can able to draw the graph. But before we draw the graph, how do you know that your graph is going to intercept on the x-axis, not on the y-axis? Guys, when you are given an equation like this, which is a central hyperbola, when x is positive, just know that this graph is going to intersect at x. All right, so let's draw our graph. Let me draw the Cartesian plane. Right, here's our Cartesian plane. Guys, when it's like this, we first draw our asymptote line here. Remember, this here, guys, is a straight line whereby we have y is equal to mx plus c. Our c here for this one is 0. So this basically means that our asymptote line, they're going to pass on the origin. You don't really have to find the points for you to draw the straight line graph. As long as you take your ruler, passing it on the origin like this, passing the line on the origin like that for this graph, and then you just name it. We name this one y is equaling to 2 over 3x. So it's the positive part of this asymptote line, is the positive one. Now you draw another line which is also passing at 0. It's also an asymptote line. There we go. These lines here, they will pass at 0. They intersect at 0, by the way. So this one here, you name it y is equal to negative 2 over 3x. So this is the negative line or negative asymptote line from this equation here. So from here, we can start drawing our graph. All right, it's time for us to draw the graph. Remember though, when we draw the graph, we know that our x is positive, so it's going to intercept at x axis. So we know that the intercept value there is going to be positive and negative 3. So on our x-axis, we want to start with 3 there, and also we have this point here which is going to be negative 3. Right, then from there we draw our graph. So we know that this graph here is going to asymptote on the asymptote line like that. There we go. And also it's going to pass here and also asymptote on this straight line here like that. There we go. And then the other one also is going to cut at negative 3 but asymptote on that line there. And then the other one also is going to asymptote here as well. As you can see, this is our central hyperbola graph. Guys, this graph is not that difficult. What you need to understand here is the fact that if it's positive like this, just know that it's gonna intersect at x-axis, and when y is negative, it's not gonna intersect at y. And also when you have a negative sign there, basically it means that this is gonna be a central hyperbola. And remember, this must be equaling to 1. So you need to simplify it further. Alright guys, if it so happen this video helped you to understand how to draw the central hyperbola, you can leave a like, a comment, and also you can subscribe if you haven't subscribed to the channel. If it happens that you didn't understand, you can rewatch the video and try to watch at the point where you got lost. And also, if that doesn't help, you can leave a comment on the comment section. I would really appreciate that. Do not forget to subscribe to the channel. We are done with 1.1. Alright guys, let's look at 1.1.1. Now we're going to copy this question, space it where there is space, and let's answer it. Alright guys, let's look at 1.1.1. Now the question is this graph a function or a relation? Now, before you answer this, you need to understand what is the difference between the two. A function is a graph whereby a x value gives you one y value. So that is a function. So how do you check? Basically, you choose any x value within the domain of the graph. And then if one x value gives you one y value, that is the function. Now, a relation is a graph whereby the x value gives you two y values. Again, you're also going to choose an x value. You draw a vertical line. So we can choose any x value that is within the domain of this graph. So for example, I will choose a point here. Let's say this point here is 4, right? So if we say x is 4, if we draw a vertical line here on the x where is 4, we'll have a point here which is going to be consisting of x is 4 and y. So we don't know y is at the moment. We can say 4 and positive y for this point here. And then when you continue like that, where the graph intersects again, we're going to have the y value here. X is going to be 4 for this point, but y is going to be negative. So it means that this is the relation, because this 4 as our x, it gives us two y values. You might not know what those values are, but we know that one of the values is going to be positive y, and then the other value is going to be negative. But if you want to know what those values are, you just have to substitute those values on the formula, which I'm not going to do, but they're going to give you two values of y. All right, so this means that this is a relation. There we go. All right, so we are done with this question. It was not containing a lot of marks. So just in case you didn't understand, you can also rewatch the video at the point where you didn't understand. And if it so happens still you don't understand, you can leave a comment. I'll try to answer you to my level best. But if this helped you to understand how to distinguish between a function and a relation, do not forget to like and share the video. If you haven't subscribed, subscribe to the channel. All right, we are done with 1.1.1. How about we do 1.1.2? Let's look at 1.1.2. Now we're going to copy this 1.1.2, paste it next to the graph, and let's try to explain the answer there. All right, guys, let's look at 1.1.2. What is it that they want here? The question goes like this. Is the graph of 4x squared minus 9y squared is equal to 36 continuous or discontinuous? Now, before you answer this, you need to know what is continuous and discontinuous. It's very, very simple, guys. A continuous graph, it's a graph that you can draw without breaking a line. An example, if I would to draw a circle, can I draw a circle without breaking the line or lifting a pen? The circle can be drawn without breaking a line. So this means that it's a continuous graph. For a straight line graph, let's see. Can I draw a straight line graph without breaking a line? Let me see. As you can see, a straight line graph can be drawn without breaking a line or lifting a pen. So this means that when you can draw without breaking a line or lifting a pen, these graphs are continuous. So what are the type of discontinuous graph look like? Now, the discontinuous graph, let me draw the Cartesian plane here. An example of a discontinuous graph could be a hyperbola. Now, a hyperbola, we know that it exists on one quadrant. In this case, it's going to be the first quadrant, and on the other quadrant, which is going to be the third quadrant for this one. As you can see, you cannot draw this graph without breaking a line. You need to draw one part of it, you lift your hand, and you draw the other part of it. While you lift your hand, this means you broke the line. So it means this is discontinuous. You cannot continue draw the entire graph without breaking the line. Another example, it's an example of a turn graph. It looks like this, by the way. The turn graph looks like this, right? As an example, as you can see, this turn graph here, you cannot draw this graph without lifting a hand or breaking a line. In order for you to complete this graph, you need to break a line and draw this part here, break a line and draw this part there, and that part there. And then also you lift your hand or break a line and you draw that part there. And then when it's like that, we call it a discontinuous graph. Now let's look at the graph that they ask a question based on. As you can see, our central hyperbola here, we have these two parts of the graph. If you draw the first part here on our left, we know that you can draw this without lifting a hand. As you can see, we can draw this without lifting a hand or breaking a line. But in order for us to complete the other half of this graph, you need to break a line or lift your hand and redraw the other part on this side. So when it's like this, we can say this graph here is a discontinuous graph. So your answer is going to be discontinuous. There we go. So that is your answer. I hope you guys managed to understand how to distinguish between continuous and discontinuous. It's pretty simple, guys. What you need to understand is when you can able to draw a graph without breaking a line or lifting a hand, that is a continuous graph. But if you draw a graph and you need to break a line to complete it or lift a hand to complete it, just know that is a discontinuous graph, just like the one that you see here on the screen. All right, I hope you guys managed to understand. If it so happen that you didn't understand, don't forget to leave a comment on the comment section or rewatch at the point where you got lost. Really, this was not challenging. But if this part of the video helped you to understand, don't forget to like, share, and also if you haven't subscribed to the channel, subscribe to the channel. Guys, we are done with 1.1.2. We are going to do 1.2. Right, we are done with 1.1.2. Now let's look at 1.2. Now 1.2, we're going to copy the question here, guys, paste it where there's space, and let's solve it. All right, guys, let's look at this question here. They say make a neat sketch of the graph x is equaling to negative y squared. As you can see, this is an inverse of the parabola graph. So in order for you to draw this graph, it's very simple. Usually you can use the table method if you really don't know how to do it in a shorter way. But with the shorter method, as you can see, this graph here, we do not have the coefficient of y and the constant. When it's like this, you first draw your Cartesian plane. Let's draw it. There we go. So here is our Cartesian plane. Now, for the fact that this y squared is negative, this means that our graph is going to face on the left. So how are you going to draw this? First of all, we know that this graph here, for the fact that it doesn't have the coefficient of y and a constant, it means that our graph is going to be intersecting at 0. So since it's an inverse of a parabola, it should face on the left like that, and also the other part is gonna be like this. There we go. So this here, guys, is our graph. There was no need for you to use the table method because this graph here is gonna intersect at 0, and for the fact that is negative here, this basically means it's gonna face on the left hand side, right? So this is the graph of x is equaling to negative y squared. Just in case you know how to draw this graph, you can go back to the beginning of this part of the video, rewatch it, and try to understand it better. If you don't understand, you can leave a comment in the comment section. And also, if you did manage to understand, do not forget to like and share. If you haven't subscribed to the channel, subscribe to the channel. I hope this was easier for you to understand, and I hope this part of the video helped you understand how to draw this type of a graph, which is an inverse of a parabola. Right, we are done with 1.2. Right, guys, now that we are done with 1.2, let's look at 1.2.1. Let's copy this question and let's try to answer it next to the graph. All right, let's look at 1.2.1. Now, the question goes like this. Is the graph x is equaling to negative y squared a maximum or a minimum value graph, right? So what you should know here is what is the maximum value and the minimum value on a normal parabola graph. Let's not forget this graph here is an inverse. So let me first explain the maximum value and the minimum value on a normal parabola graph. Let's say this graph looks like this. Let's say it's a parabola graph, x and y there. Let's say it's facing upwards like this, right? Now, when a parabola graph faces upwards like this, we know that our x squared coefficient, which is a, is going to be positive, right? We can say this graph here is actually minimum. The reason why we say minimum is because at the turning point, let's say our turning point is here. At the turning point, the y value here, it's actually the lowest point that a graph has. So at the turning point, the y value of that turning point is the lowest point of this graph here. So when we seek for maximum and minimum, when the parabola is not inverted, we look at the turning point, but we look only at the y values, right? So when it's facing upwards like that, and when a is positive, the graph is said to be minimum value. But then when it's facing downwards, let me just be quick about it. Right, when it's facing downwards like this, as you can see, we're also going to look at the y value. The highest y value we can ever have here is the y value of the turning point on this graph. So it means that this is going to be a maximum value. There we go. So we're also going to look at the y value, and also we look at the turning point. Coordinate of the turning point, which is y, is the biggest. Now it means that this is the maximum, because from the turning point, the y value actually decreases. So this we say is the maximum. Now, since we have our graph, which is inverted, we also gonna invert how we actually check whether it's maximum or minimum. Instead of using the y values, we use the x value. If you can see our graph here, it cuts at 0 here, and then it moves towards the negative x there. Meaning now, this x here, it's our actually turning point, which is going to be our coordinate and is equaling to 0. Other than that, there's no any other point here that is going to be bigger than x when it's 0. So we can say this graph here is maximum. There we go. So from there, going this way, all the x values at this point are minimum. So I hope you managed to understand this. Really, it was not that difficult. You just needed to know on the original or on the parabola that is not inverted how to get the maximum and the minimum. Then from there, you just swap the values. Right, I hope you understood, guys. If it so happened that you didn't understand, you can rewatch this part of the video at the beginning of this question and try to make sure that you listen carefully. If you didn't understand either, you can also leave a comment. I'll try to answer you to my level best. But if this part of the video helped you understand how to distinguish between the maximum and the minimum of the inverse parabola, you can leave a like, and also if you haven't subscribed, subscribe to the channel. We are done with 1.2.1. How about we look at 1.2.2? Right, now that we're done with 1.2.1, let's look at 1.2.2. As you can see, here's the question here. I'm going to copy it, paste it next to the graph, and try to answer this the way that you can understand. Right, let's look at 1.2.2. So the question goes like this. Is the graph x is equaling to y squared symmetrical about the x-axis or the y-axis? So they mean that is the x-axis or the y-axis cut our graph into half. They are saying that is our graph half at about x-axis or the y-axis? So when you look at these two axes here, which of the two axes cut our graph into half? Now our y-axis doesn't even cut it, it's just touch it at the point, so it's not the y-axis. But when you look at our x-axis, let me just write it here, from 0 going this way, it's actually cutting our graph into half. Look at that half and the remaining half there. We can say our graph is actually symmetrical about the x-axis. So your answer, you can say about x-axis. There we go. There's your answer. Guys, I hope you managed to understand this. Really, it wasn't difficult. Just in case you didn't, you can go to the beginning of this question, rewatch it. And also, if that doesn't help, do not forget to leave a comment in the comment section. Right, if this part of the video helped you to understand, do not forget to like, share, and also subscribe to the channel if you haven't subscribed to the channel. Right, we are done with 1.2.2, and also we are done with question 1 as a whole. I hope this video helped you to understand how to answer the questions on this question paper. All right, so guys, we are done with question 1. How about we do question 2? So at the end of this video, I will leave a playlist where I recorded all the questions. You can click on that playlist and select the question that you want to watch, and also the full video as well if you want to watch from question 1 to question 5. Right, guys, thank you very much for watching. We are done with question 1. Next time we'll do question 2. Till next time, guys, cheers.